In the example we're talking about today, MRSA or methicillin-resistant Staphylococcus aureus, the story is a little bit different, okay? Staphylococcus aureus is not a bacteria that is normally a pathogen like strep throat or tuberculosis. Staph aureus lives on your skin normally, and so we call this a commensal bacteria or a normal flora, right? Staph aureus lives on your skin, it eats dead skin cells, and it basically occupies space. So it's providing a service in that by occupying that space, it's keeping out bacteria that could infect you, right? So normally, Staph aureus is providing a service when it lives on the surface of your skin. It doesn't normally cause any infection. The only time it causes an infection is when you have a pretty serious wound or when you end up in the hospital and you have a surgery that creates a wound, right? And sometimes Staph aureus ends up in a place where it doesn't belong. So it might end up in the bloodstream and cause an infection there, right, where your body doesn't know how to handle it. Okay, so why does Staph aureus evolve resistance to antibiotics? Okay, the problem here is that Staph aureus lives on your skin all the time, right? So when you take an antibiotic for strep throat or anything else that infects you, that Staph aureus that lives on your skin is getting exposed to that antibiotic. That means that Staph aureus gets exposed to lots more antibiotics, probably even than pathogens do. Okay, so if you've been taking a lot of antibiotics, it's quite likely that commensal bacteria like Staph aureus that live on you will have acquired resistance to some antibiotics. Since I know something about the evolution of antibiotic resistance in bacteria, I'm particularly bothered by the recent trend of putting antibacterials in products like hand soap. Antibacterials are just antibiotics that have been labeled with a different name, and maybe you should be alarmed that we're putting this hand soap with an antibiotic in it onto our hands every day where our commensal bacteria are going to encounter it. Okay, the first problem is that adding the antibacterial to the hand soap doesn't seem to add any benefit. So if you ask people to wash their hands with soap that doesn't have antibacterial, and ask another set of people to wash their hands with soap to which they've added an antibacteria, they wash their hands like we all do, put some soap on, rub them together for about 6 seconds, and then rinse it off. 6 seconds isn't a lot of time for that antibacterial to do anything. And when they count the bacteria that have been removed from both of those sets of people's hands, it didn't make a difference whether the antibacterial was in the hand soap or not. The same number of bacteria were removed with the regular soap as were removed when they added the antibacterial. So that's one problem, but maybe that's a smaller problem. The second problem is that, again, because your commensal bacteria are encountering this antibacterial all the time, you wonder whether that is going to select for the evolution of resistance to that antibacterial, right? And this is a particular worry because we know a little bit about the mechanism by which such resistance can evolve. So one way that you see resistance to antibiotics in general evolve is that bacteria make a thing called an efflux pump on the surface of their cells, and that pump works to pump out toxins from the cell, right? Antibiotics are a toxin, and some of them can get pumped out through these efflux pumps. The way that a bacteria can evolve resistance to an antibiotic then is to increase the number of those pumps that it makes, right? If it makes more pumps, it can pump the antibiotic back out of the cell faster. Okay, and resistance to the antibacterial that's in hand soaps can work this way, right? That a mutation arises that causes the cell to make more of those pumps, and so they pump that antibacterial back out of the cell a lot faster, and the bacteria survive. The problem with this type of resistance mechanism is that those pumps are not very specific. So they pump out that antibacterial, but it turns out that they pump out a lot of different toxins, including a lot of medically relevant antibiotics. So the worry is that if this antibacterial that's in hand soap were to cause the evolution of resistance to that antibacterial, that you might get resistance to other medically important antibiotics coming along.